Well, today is the third lesson of talking nonsense about DN training and TLP. Simple implementation of DMA Firmware Lock. Then the DMA Firmware Lock. First, let's talk about DMA is, well, a device identifier. Take one of our ID cards. Each chip, including our current 85T and 75T. Each board, it has its own independent, a device identifier. This marker, it can be used in our firmware. Make a judgment. Well, that means you can generate a firmware sample. A specific device identifier. The LAMP firmware works, and other firmware doesn't work. Yes, let's talk about this first. Well, one of the principles of DNA. Later. Well, this is an apt document. Then search for DNA and find out what is DNA that is not. Well, even the cup is a saying. To put it bluntly, it is a calculator. But it is not one of our IP studies. Yeah, regular calculator. It is a non-conscious. It's a one-time programmed calculator. Just use fuse technology. Go and compare the approximate value of this cup. Solidify into our film. Then later. Well, what about after this value cannot be modified? Well, in our 7 series. What about in the series? Okay, the length of this DNA is a 57-bit length. Again, in a film in the series of Aki's Q. The length of DNA is 96 bits. And well, let's take a look at this DNA. One of them. This is an anowned interface to DNA. It has a clock and a shift signal and stoppage time. There is also a physical output. Well, normally it's a 7. A 10-bit DNA of the series. This is a 57-bit. Well, it's this. What about primitives at work? It starts with us pulling up a Y signal. What about after it's pulling like taking this DNA, fill in this shift register. And then what happened? We're going to pull up this shift signal for 57 clocks. Register the value inside that bit. Move them out one by one. Then we go to be displaced by this. This DL signal. Store one by one. You can get a 57-digit one later. The value of a DMA. This is a value for this chip. Well, what about the principle of forgetting? Let's look at a project. Well, our project. You can also see it here. It may be possible to search for this DNA for this reason. This one. We can instantiate a primitive directly. Of this class. Put our own in that project. What about a patient in the original language? It is consistent with what was said in the document just now. And then, how is DNA going to get into our projects? Well, I've got a DNA. Locked a module. Let's look at the top floor. Inside the top floor of this project, I instantiated such a module myself. This is a module of DNA that I wrote myself. And here, it is a value of a DNA that has been acquired. How are we going to get this DNA value? Well, I use it directly here. He shared a tool for DNA retrieval. Then, for example, my board is a 75T board. Then I'll just double-click. I can get it. What is my DNA value? Is a value of 57 bits. Behind the tool, I will also upload it to the group. Like what? This is a DNA value of our channel. I just want this. a DNA lock. A plate of this DNA value will work. Then I will fill in this value here. Then it is in this module. It will be in the electricity. To read the DNA value of this chip, compare with this value. If it is this value can be compared to normal. Then this log will be raised. That is to say, if the log is pulled up, will affect this. This logic is control a reset of all modules. If this log doesn't go up, all the following modules are in a reset state. There will be no way to work normally. This is where we go home. A logic of that DNA lock. I mean, if this thing doesn't match me. In this way, all projects are in a reset state. Well, it doesn't work like this DNA board. How do you implement the DNA module? The DNA module is very simple. That's the first instantiation. The module we were talking about earlier. Then we generate a logic. Just go and pull up the signal at this bit, then shift 57 times at the same time. The logic behind this is, I generated a counter. When you want me to wait for 100 I'm going for to this counter. Let him take that DNA. Fill in that shift register. And then I'm pulling up 57 clocks later. Then put this the value of BEMA is read from this signal. After reading it out, I deposit it here. Then read it out. What about after depositing it? And then I'm just following the DNA value that I passed in. Make a comparison. If the comparison is the same, then this higher signal value means that the comparison was successful. This module of mine works. Otherwise, it doesn't work. Okay. I will also upload the latter module to the group. Then you can pick it up. Today's explanation of this BEMA? Just about here. Next issue, maybe I'll share a straight line with you. A method of that I/O bully.